Hi students, this is AJ sir. Let's study 9th standard ICSE Math 4E. Now in exercise 4E, question 1.4 has 3 brackets. The question is simplify. Cancel Roman number 1 and Roman number 2. It's of the same type. So how do we simplify this? Well, in math, the easiest way to simplify anything is by making it disappear. But here we will just have to open the brackets. Let's take the first 2 brackets. So keep the third bracket as it is. Distributive multiplication, use square brackets. Bring like terms together so we get 1 bracket. Now we are left with 2 brackets. So once again, distributive multiplication, first term into the whole bracket, plus second term into the whole bracket, minus third term into the whole bracket. And once again, open all the brackets, get the like terms together. This gets disappeared. This is minus 28x, and this is the final answer. Now let's study 3 new formulae. One is a cube plus b cube, which is a plus b, a square minus ab plus b square, and this is the formula for a cube minus b cube. Now the difference is, if there is a plus here, then there will be plus in the first bracket, and if there is a minus, then there will be minus in the first bracket. In the second bracket, on the other hand, if it is a plus here, then it will be minus and plus, and if it is a minus, it is plus and plus. Then we have one more formula, which is a plus b plus c, and multiplied by a squared plus b squared plus c squared minus ab minus bc minus ca is equal to a cube plus b cube plus c cube minus 3abc. So using these formulae, let's solve ahead. Let's come to question 2.1. We've been given this bracket into this bracket. We have to solve this using this formula. There should be a plus and minus sign here. I see the first bracket has a plus sign, so definitely the formula to be used is a cube plus b cube. So let's convert this into that form first of all. So the first bracket remains as it is, and the second bracket will become a square minus ab plus b square. So now this is a formula. It is a plus b, a squared minus ab plus b squared, and that is nothing but a cube plus b cube. So we've condensed this using the formula and simplifying it further. This is the final answer. Now in Roman number 3, again we have 2 brackets. Notice in the first bracket we have a minus sign, so this is a hint that here we will use a formula a cube minus b cube. But first we have to convert it into that form. So the first bracket remains as it is, but the second bracket will be of the form a squared plus ab. See how 3 and 3 will get reduced and ab would be left as the middle term here, plus b squared. So now that it is in this form, we can use the formula a cube minus b cube and simplify it further. This is the final answer. Question 3.2, 97 cube. This will become 100 minus 3 the whole cube, and we use the formula a minus b the whole cube is equal to a cube plus b cube minus 3ab in bracket a minus b. And then we simply solve, add, subtract to get the final answer. Now in 5.2, mark this as IMP, and even mark 2.3 as IMP. Now there are so many decimal numbers, addition, subtraction, multiplication, but the beauty of math is that often we can find patterns in it and use formulae to make calculations easy. So first of all, we will convert it into the form of 1.2 the whole squared plus, well, just multiplication of the 2, and even this is a square. The denominator becomes 1.2 cube minus 0.3 cube. The denominator is a cube minus b cube, and we know the formula for that. It is a minus b, a squared plus ab plus b squared. Now interestingly, this second bracket is exactly the same as the entire numerator. That means no need to solve or open the brackets anymore, just cut it. So what is left is 1 upon 1.2 minus 0.3, which is 1 upon 0.9, into 10 to get rid of the decimal place. That's 10 upon 9, and the mixed fraction answer, which is compulsory, is 1 upon 9. In question 7, the value of x plus 5y is equal to 10 is given, and we have to find the value of this expression. Now, if you look at this question, it's clear that we'll have to cube the given data. So we'll start with that, cubing both the sides, and use the formula of a plus b the whole cube, which is a cube plus b cube plus 3ab, a plus b. And here this bracket's value is already known as 10, so substitute that, solve further. Now, this seems to be similar to the expression which is given. And if we solve it, we realize that indeed it is exactly that. There should be 150 out here. And if you shift 1000 on the left hand side, minus 1000, we get the answer as 0. That is indeed the final answer. Now the last question, question 10. Question 11 can be cancelled. It's not important. If x, y and z are three different numbers, they could be any number, then prove that this expression is always positive. Now to prove this sum, you'll have to remember one manipulation here. We'll have to multiply the numerator and denominator by 2. The reason behind this will be seen shortly. We do distributive multiplication. So we have 2x squares, 2y squares and 2z squares. And these terms look like the middle, one of the terms of a formula here. We'll rearrange the terms. Let's go for x square, y square and minus 2xy. So that's one group. Then let's go for x squared, z squared and minus 2zx. That's another group. And the remaining y squared, z squared and minus 2yz will be the third group. This has become a formula. This is x minus y the whole squared, x minus z the whole squared and y minus z the whole squared, the whole upon 2 of course. Now irrespective of whether x or y are positive or negative numbers, but this, even if you subtract it and you get a negative answer, but the square of it is always positive. So this term is always positive. This term being a square will always be positive, and this term will also be a positive, and of course upon 2. So the entire expression is definitely a positive number, as it is a sum of squares. Therefore the given expression is also always positive. That is, this given expression is definitely always positive. It doesn't matter whether x, y and z individually are positive or negative.